Welcome to the AI Research Roundup. I'm Alex. Today we're looking at a paper from the Hugging Face trending list, published on March 2nd, 2026, just 2 days ago. It introduces a battery-included open-source library that automatically selects the optimal training strategy for natural language tasks based on your dataset size, removing the need for manual tuning. The paper is titled OpenAutoNLU, Open Source Auto ML Library for NLU. And as we'll see later, this unified framework offers some compelling advantages for both efficiency and model quality across diverse benchmarks. And for those interested in the implementation, the authors have shared their code on GitHub. Figure 1 maps out the pipeline flow, starting from the auto classes at the top. The core logic sits in the adaptation block, where the data and method synergizer analyzes your input. Depending on the data size, the system selects a specific training strategy, ANC set fit for scarce data, set fit for few shot scenarios, or a full fine-tuner. Below that, the out-of-distribution detection module adds safety checks using methods like marginal Mahalanobis detectors. Finally, the bottom layer handles persistence, exporting optimized models for inference. So, while Figure 1 outlined the system design, Figure 2 highlights the practical trade-off between performance and training cost. The chart plots the macro F1 score on the vertical axis against training time in seconds on the horizontal axis. You can see OpenAutoNLU represented by the purple cross sitting in the ideal top left corner. It achieves the highest accuracy, around 0.78, while finishing in under 200 seconds. By comparison, the orange triangle for AutoGluon shows similar accuracy, but takes over 1400 seconds, which highlights the substantial efficiency gain of the proposed library. So, while Figure 2 focused on speed, Table 1 compares feature sets across leading AutoML frameworks. It lists OpenAutoNLU in the far right column against competitors like H2O and AutoGluon. The top rows show that unlike general tools, this library is built for encoder fine-tuning and handles scarce data down to just 2 examples per class. In the middle section, it stands out with large language model integrations for synthetic data generation. Finally, the bottom rows highlight that it is the only solution here with built-in data quality evaluation. Well, moving from features to raw performance, Table 2 benchmarks the F1 scores for both standard classification and out-of-distribution detection. The first 2 rows display OpenAutoNLU's results in supervised and unsupervised modes, while the bottom section shows the competitor, AutoIntent. A standout finding here is the unsupervised, out-of-distribution detection performance. For example, on the Banking 77 dataset, the unsupervised model achieves an out-of-distribution score of 0.43. This is significantly higher than AutoIntent's best supervised attempt, which only reaches about 0.18, proving that the library handles unexpected inputs robustly, even without explicit training labels. Okay, while the previous table looked at detection, Table C1 focuses on pure in-domain classification quality using the full datasets. The top row highlights OpenAutoNLU's performance, where it claims the highest F1 scores on the massive and SNPs benchmarks, hitting roughly 0.88 and 0.92, even where it doesn't win. Like on Banking 77, it remains very competitive with AutoGluon, shown in the second row. In contrast, looking at the bottom rows, it substantially outperforms other alternatives like AutoIntent and H2O, confirming its strength as a general-purpose solver. So, while the previous table looked at overall accuracy, Table C2 details performance based on data availability. The columns group results by shot count, from just 5 to 10 examples up to the full dataset. In the top row, OpenAutoNLU scales consistently, hitting 0.95 on SNPs with full data. Conversely, the second row shows AutoIntent winning in the scarce 5 to 10 shot category, but surprisingly dropping off as data grows. Finally, AutoGluon in the third row displays the inverse pattern, struggling with few shots but excelling when fully trained. Wrapping up, the main takeaway is that OpenAutoNLU effectively democratizes advanced natural language processing. By automatically selecting the best training strategy, from few-shot learning to full fine-tuning, it delivers expert-level performance without manual overhead. This adaptive approach significantly lowers the barrier for building robust text models. That's it for this episode of the AI Research Roundup. I'm Alex. Thanks for listening.